Hello friends, welcome you all. So in this video, I'm going to discuss one general logic of creating machines for accepting strings, that is having number of zeros divisible by particular number m and number of ones divisible by any particular number n. So for explanation purpose, I will take the particular value of m and n, and then I will tell you the logic, and you can apply this same logic for any value of m and n. So I will take here m equals to 3. I will take here m equals to 3 and n equals to 2. Now you can see the friends. We need to accept all binary strings. So obviously zeros and ones. If in strings zeros and ones are there, then these are binary strings. So we need to create DFA for accepting all binary strings having number of zeros divisible by 3 and number of ones divisible by 2. So that how we can create such machines. So let's see, and then you can apply the same logic, you can extend the same logic for any value of m and n. So now as we need to create the number of zeros divisible by 3, so divisible by 3 means 3, 6, 9, 12, like this, any number may be there. So what we can do, we can create a machine for accepting three zeros. So I can create like this. So this would be my accept first state, initial state, and then it would be 0. See, the number of zeros divisible by 3, it means number of 0 may also be 0. So that means we need to accept epsilon. And if we are accepting epsilon, so we need to make initial state as final state. So now this would be, we reach here, then on 0, number of 0, 2. So we will reach here, and on third 0, we can move back to final state. So that would be the machine for accepting strings having number of zeros divisible by 3. Now we one more thing we need to add here, number of ones divisible by n, and where n is 2. So number of ones divisible by 2. So what we can do, we can have here one state, and we can extend this state here like this. So on applying 1, we will reach to this state, and we have got one single one now, and we have to add one more to get it accepted. So now you can see the number of ones are divisible by 2. Number of ones are divisible by 2. Now this particular machine will be accepting all the strings having zeros divisible by 3 in a sequence, and then ones divisible by 2 in a sequence, or 1 and 0 may be in any sequence. Either all the 1 may be first and the zeros may be second, but all the zeros may be on first place, and then all the ones may be on second place. Now we need to generalize the things on. We need to make any machine that can accept any position. Only the number of ones and zeros must be satisfying a condition. So we can extend all these states here like this. So I can write 1, and I can write like this 1, and I can have this also, like this 1, and like this 1. Now the same transition we can make for this also, like this, and like this 0, 0, 0. So now this is the machine for accepting all strings having number of zeros divisible by 3 and having number of ones divisible by 2. So now you can check any string for this. Now we will take some example of valid strings, and some example of invalid strings also. So first we are taking the example of valid strings. So for this particular machine, the number of zeros must be divisible by 3 and number of ones must be divisible by 2. So we are creating 0 0 0 1 1 1 1, right? So this should be accepted because the number of zeros are 3 and number of ones are 4. So these are divisible by 2 and these are divisible by 3. So it must accept this string. So let's see whether it is accepting or not. So we are on this state Q0, we are on Q1, Q2, Q3, Q4, Q5. Q5. Now you can check. So we are on Q0 and we are reading 0. So we will move to Q1. We are on Q1 and we are reading 0. So we will move to Q2. We are on Q2 and we are getting 0. So we will again move to Q0. Then we are on Q0 and we are getting 1. So we will move to Q3. And we are on Q3 and getting 1. So we will again move to Q0. Then we are on Q0 and we are getting 1. So we will move to Q3. And we are on Q3 and we are getting 1. So we will again move to Q0. And now string is complete. So after reading complete string, we are on Q0, which is a final state. So this string is accepted. Now, I'm taking one more example where zeros and ones are distributed in any sequence, like 1 0 1 0 1 0, like this, right? So now you can see we are on Q0 and we are getting 1. So we will reach Q3. We are on Q3 and we are getting 0. We are reading 0. So we will reach to Q4. We are on Q4 and we are getting 1. So we will move to Q1. We are on Q1 and we are getting 0. So we will move to Q2. We are on Q2 and we are getting 1. So we will move to Q5, and we are uh, on Q5 and we are getting 0. So we will move to Q3. And in this particular string, you can see this is not the valid string. So we are on Q3, which is not final state. So this string will not be accepted. Now, I will take one more example. 1 0 1 1 0 0 1. So now number of zeros are 3, number of ones are 4, so it must be accepted. This is the valid string. So now let's see. Now we are on Q0 initially and we are getting 1, so we will move to Q3. We are on Q3 and we are getting 0, so we will move to Q4. We are on Q4 and we are getting 1, so we will move to Q1. We are on Q1 and we are getting 1, so we will again move to Q4. We are on Q4 and we are getting 0, so we will move to Q5. We are on Q5 and we are getting 0, so we will move to Q3. We are on Q3 and we are getting 1, so we will again move to Q0. So after reading complete string, we are on Q0, so this string is accepted. That means all valid string having satisfying this criteria will be accepted, and all invalid string will not be accepted. So I hope this is very much clear to all of you. And one more important thing, now in such a machine, how would you decide the number of states? So you can see we need to check the number of zeros divisible by 3, and we need to check the number of ones divisible by 2. So number of states here in this machine, you can see 6. That means 3 into 2. 3 into 2. 3 multiplied 2. So that is number of states. So now, if you are creating a machine for accepting strings having number of zeros divisible by 4 and number of ones divisible by 2. So number of states in this machine would be 4 into 2. 8 number of states would be there, and within 8 states you can create such machine. So this is one more concept. So you can extend this concept for any value of m and n. I hope it would be very much clear. If you have any doubt, you can write me in comments. I will definitely reply your comments. So thank you so much.